Determine whether the integral is convergent or divergent. Evaluate if convergent. The integral from 1 to infinity, 1 over x squared plus x dx. This is an improper integral. We can see that by the infinite limit of integration. So we use the definition. So the limit as b goes to infinity, the integral from 1 to b, 1 over x squared plus x dx. So we're going to have to find an antiderivative of that 1 over x squared plus x. Let's go over on the side and get that done. Notice that x squared plus x is equal to x times x plus 1, just factored. And you notice that we're going to have to do a partial fraction decomposition here. So 1 over x times x plus 1 is equal to a over x plus b over x plus 1, multiplying by the common denominator, which is x times x plus 1. We see that we have 1 equals a times x plus 1 plus b times x. Combining like terms on the right, we get a plus b x plus a. Now we equate coefficients. So a plus b has to be 0. A plus b is the coefficient of the x on this side. The coefficient of the x on this side is 0 because there isn't an x term. Also, we know that a is equal to 1. Well, once we know that a is equal to 1, we can say that 1 plus b is equal to 0, which means that b is negative 1. So, the integral 1 over x times x plus 1 dx is equal to the integral 1 over x plus negative 1 over x plus 1. We can break that up into two integrals and essentially be done there. So the integral 1 over x dx minus the integral 1 over x plus 1 dx. This first one, natural log absolute value of x, minus, now over here technically we would have to have ourselves a little substitution, so let u be equal to x plus 1, du would be equal to dx, so we would have the integral 1 over u du, which is natural log absolute value of u, and u is equal to x plus 1. So in the end, we end up with a natural log absolute value of x plus 1. So there's an antiderivative. We can take that back up to our integral and limit that we're really talking about here. Limit as b goes to infinity, natural log absolute value of x minus natural log absolute value of x plus 1, evaluated from 1 to b. Now when you subtract two logarithms, you can actually combine them into one logarithm. So this becomes the natural log absolute value of x divided by x plus 1, evaluated from 1 to b. Now evaluating that antiderivative, we substitute in b first. That's the upper limit of integration. So that's the natural log absolute value of b divided by b plus 1, minus the natural log of 1 divided by 1 plus 1. Of course, that second natural logarithm is just going to be the natural log of 1/2. And when you take the limit of that, that's what you end up with, because that is simply a constant. And so when you take the limit of a constant, you get the constant. However, the limit of the natural log of the absolute value of b divided by b plus 1, this becomes the natural log of the limit b over b plus 1. That limit, b is going to go to infinity because that's what the limit says is happening. B plus 1 also goes to infinity. So this is an indeterminate form. You can do L'Hopital's rule. So this becomes the limit of the derivative of the numerator, which is 1, divided by the derivative of the denominator, which is also 1. We still have our natural log of 1/2 just kind of hanging out. The limit of 1 over 1 is just 1, and the natural log of 1 is 0. So that whole term just goes away. And so we have left negative natural log of 1/2. So the integral from, what were our limits of integration? 1 to infinity. 1 over x squared plus x dx converges and is equal to negative natural log of 1/2.